Hi everyone, it's Omwakin here and welcome to my YouTube channel. So this episode, like I said, from the last episode I introduced what we're going to be doing in this series, right? So if you've not watched the last episode, go watch the last episode so that everything makes sense to you. Then in this episode I'm going to be focusing on some questions that are really needed. It's not going to be a tutorial video where I think even if it's a documentary, for you to fully understand or follow along, you have to have some fundamental knowledge or understanding of certain things that you would then build upon to fully grasp and understand what I'm trying to do in this series. I also wanted to put this out there. I would hardly be doing live coding because, again, building a programming language isn't as trivial as like building a side gig or side project. It's a bit more complicated than that. So because of the time frame, I want to keep all my videos. I won't really be doing a lot of live coding. I would try to do some, but I would have worked on some of the bits that I want to present in the video prior to the video, right? So at least I would then try to work us through what I've done so far and what needs to be done next. So at least we have an understanding. Like I said, it is going to be a documentary. So I'm just documenting what I'm doing, which is building a programming language from scratch, right? And I'm glad you want to follow along with me on this journey. So first question is, what's ProScript? ProScript is a programming language, and it's an interpreted programming language to be specific. So that leads us to the next question. What is a programming language? So just think about it like this. It's a set of instructions that you write in a programming language. It's just like a normal human language. Like I'm communicating to you in a language now, which in this case is English. Or you could decide to translate it to your own desired speaking language. It could be French, it could be Spanish, it could be German, it could be anything, right? That is a language. So a programming language is just a class of language, but in this case is understood by computer systems. So that brings us to the second question. What is a computer system? In the context of a programming language, a computer system is quite broad. I'll keep it very simple. In the context of a programming language, a computer system is a machine or a box that reads your set of instructions, which you've encoded in your programming language, and performs set tasks based on those instructions, right? For example, if you say, open a file, right? You've encoded that instruction in whatever programming language you're writing. So the opening of a file that a computer would eventually do is as a consequence of that instruction you've written in your programming language. So that's basically it. It's that simple, right? Next question is, how does a computer system understand programming languages, right? We already know what a programming language is, at least on the on a general scale. So let's answer the question of how does a computer system understand programming languages. So for us to answer these questions, we need to take our understanding of what a programming language is a bit further. So there are different types of programming languages. Typically, there's a high-level language, there's a low-level language. Sometimes there's a mid-level language sometimes, right? But let's just think about it as a high-level and low-level language. So a high-level language is one that are closer to our human languages, right? Like English, like French, like German, even Yoruba, which is my native language. So those are high-level languages. They are very close to them. So we humans can still really understand them to a point, or significantly, for us to even be able to write them. Then there's another class of language, which is the low-level language, which is very close to the computer system. So we have the assembly language, and sometimes we can say C or C++, for example, depending on how you want to say it. Those ones are closer to the computer system, and they are easier to understand by the computer system because they are very, very close to computer systems instruction map, right? So they map almost one-to-one to instructions on the computer system. Like I said, this is not going to be a beginner focused video because this is not a beginner focused topic, right? I want to believe you, like I said in the last episode, I want to believe you have at least an understanding of what programming is, or have worked with programming languages in the past, or you've written code, right? So that's when you can fully understand or appreciate what's going on here. But that doesn't mean if you're not, you can't follow along. You can still follow along, right? I'll try to make it as simple as I can, but again, keep in mind it's a very complicated and advanced topic, so don't beat yourself so much if you don't get it right out of the box, right? Okay, so a high-level language maps to several low-level language instructions, right? And a low-level language maps to fewer computer instructions, right? Or computer instruction sets. I think you can see where the thread is going now. There's a mapping from a high-level language to a low-level language, and the low-level language then maps to actual computer instruction sets. For example, now, let me say my native language, which is Yoruba, is an high-level language, and let's say English would be my low-level language. The actual instruction that I perform based on that language is the computer instruction set. A sentence would be Otide in Yoruba, which is, let's say, a high-level language. Mapping to English would be arrived, right? Which is a lower-level language, and a person arriving will be the instruction set which executes on the computer system. There's a mapping between languages, and that is how a computer system typically understands programming languages, right? There's a high-level language that we write. For example, ProScript is a high-level language that would map to a lower-level language, right? And that lower-level language then maps to the instruction sets of the computer system, right? For example, opening a file would map to opening a file instruction in a lower-level language. The lower-level language would then map to opening a file instruction set on the computer system, which the computer would then execute and open a file. So that's the simplest fundamental idea of how a computer understands programming languages, right? It's a bit more complicated than that, but that's like the simplified or simplification of the entire process. So there could even be several low-level language in the middle, right? It's like I said, there's a mapping. You could have several. You could even have high-level language mapping to another high-level language, mapping to another high-level language, which eventually maps to several low-level languages, and then maps to the computer set instructions. You get? An example would be TypeScript, which then maps to JavaScript, which then maps to maybe C++, which then maps to an assembly code, which then maps to a binary set of instructions, which then maps to an instruction set on the computer system. It could come in any flavor, right? Depending on what the designer decides to go with, right? Hi guys, I'm working again. So we've come to the end of this episode. I'm going to be treating the last two questions: what makes up a programming language and how to create a programming language in the next episode. So do subscribe if you've not subscribed so you don't miss out on this video when it comes out. Those topics deserve their own conversation, and that is why I'm going to be dedicating the video for them so we could go in depth into some of the design decisions I made in creating ProLang. Bye.